Hello there, crypto fans, and welcome back to the New Blocks episode number 9. Today we are talking consensus. Kevin, welcome back again. Excited. Can't believe we've got 8 of these done already, and there's still some people with us diving further down the rabbit hole. I can't stop seeing that meme of Alice falling down the hole.
Yeah, I'm surprised that, people are digging this content. I saw something like 300 views on the first episode. That's 300 more than I would have gotten just uploading videos by myself. So appreciate you bringing some audience here. These have been flying by. I'm
Absolutely
excited to get into episode number 9.
Yeah, and it's still exciting times in the blockchain world. You know, it's kind of ebbed and flowed over times. We've had these way crazy ICO times in the past, and then these drawbacks where it's very sad. You know, I've got a Litecoin miner that I've run at various times. I've been a subscriber to /r LTC mining, and I'll tell you, bud, it's either real happy or real sad. It's kind of like the craps table, and it's fun to be part of the roller coaster. I have to admit, I just plugged the old L3 back in. I'm profitable by 30 cents a day, roughly speaking. So
now you're really rolling in it.
You know, yeah, there was a halving not that long ago, so I'm on track to get 0.001 of a Litecoin in a couple of days. Should be pretty exciting.
Keep
pretty
me
cool.
Posted when that happens. That's going to be
big bucks, buddy. Yeah,
super duper.
Yeah. To the moon we go. But what are we talking about today? Consensus. What are we diving into?
Yeah, we've talked about a lot of this at sort of high levels. Episode, I believe it was 3, we talked about blockchain and consensus. It goes hand in hand. And so we're going to dig a little into the actual hardware that's running the blockchain and what it means to derive consensus from the network. So the first term that we've probably mentioned before is this concept called a node. And a node is essentially an instance of some hardware that runs a version of the blockchain. So we've mentioned in the past that anytime that anyone wants to derive some sort of value from whether it's Bitcoin or Ethereum or any of these other blockchains, they may at some point be incentivized to run a node. So if you have a business that relies on receiving Bitcoin or Ethereum, or maybe you just hold a decent amount of a given currency, you are monetarily incentivized to help support the security of the network. And that's really what a node does. It runs a copy of the blockchain. It continues to synchronize with the rest of the network, and it validates all of the incoming data that is being entered into that blockchain through new transactions.
So it's sort of like I'm seeing this onion in my head with multiple layers of decentralization here. Not only is the blockchain itself decentralized in nature with these miners and all these different actors, but the nodes all act sort of like Wi-Fi repeaters, right? They all talk to each other and they all strengthen the signal of the network. So if one of them goes down, it gets rid of this problem where if there's like a fire in a data center somewhere, it doesn't really matter because you have all these other copies of the blockchain across all these other computers that are all talking to each other at the same time.
Yeah, exactly. And every time we spin up a new node, the network becomes that much stronger and that much more decentralized.
Right.
It goes back to this idea of you look at something like Binance, their smart chain. It's run entirely by the Binance company, and so they could run one node, 1,000 nodes, 100,000 nodes, but it won't so much matter if they're all controlled by one company or one group. And so, breaking the network and spreading it out as much as possible, spreading out the surface area, that kind of helps to decentralize it and helps to make that a little more trustworthy.
Gotcha. So TLDR, a node is just a copy of the blockchain that exists somewhere on the internet. That's it. Yeah. Anybody can run a node. Really, that doesn't take any special hardware or computing power. It just takes, I guess at this point, a good bit of memory.
Yep.
A little bit of hard drive space. Yeah.
Yeah, and so the node's job is to run what is known as a consensus algorithm. And that a consensus mechanism is just a series of steps that the node can take to establish consensus with the network. And so we go back to prior to blockchains, the way that you would establish any sort of consensus in a group of people is that you would have this sort of authority figure. So you think of something like Facebook.
Mm-hmm.
The current state of the Facebook website and platform is dictated by this company called Facebook, and there's no real need for you or I to sort of disagree what is on Facebook, because we can both just go look at it, and there's this authority figure that sits in the middle and says, okay, this is allowed on Facebook, this is not allowed. Doesn't matter really what anyone else says.
Right.
Whereas in blockchain world, we use this series of steps to help establish what that current state of the network is, without any sort of a central intermediary that helps us to achieve that.
I see. So, by nature of the blockchain being decentralized and having so many individual actors, we're constantly paranoid. We constantly have to check ourselves and make sure that everything's working according to plan. So, this consensus mechanism is basically the thing that holds all of it together. That it's sort of like that social glue, I guess, in the blockchain world.
Yeah, and if any of our viewers have ever downloaded anything with uTorrent, you could think of uTorrent, the software, is in charge of communicating with the network and finding seeds for a given file, and sort of being able to send the data from your machine to others. So the consensus mechanism similarly is in charge of facilitating the information around the network,
Mm-hmm.
so that we can achieve a level of agreement toward what the next block is, and therefore what the information on the network is.
Yeah, that makes sense. And a quick recap, I guess, for anybody who doesn't know what uTorrent is or BitTorrent, it's this idea of file sharing where instead of like the old example was Napster, where Kevin has a file on his computer, I connect to his computer, I download that file in its entirety to my computer. That's like peer-to-peer file sharing. BitTorrenting is where there might be 100 different seeds just like Kevin out there that have that same file, and I'm getting little bits from each person that come together to make that file for me. But how do you organize those little bits coming from all those different places? That's the mechanism we're talking about.
Yep. And there have been a lot of, I wouldn't say a lot, but there have been a few different consensus mechanisms that have been experimented with since the creation of the blockchain. So Satoshi Nakamoto releases Bitcoin and releases the first consensus mechanism, which is called proof of work. And so this is the idea of miners. They run hardware that burns electricity and uses that electricity. You could think of it as sort of a trust collateral, where if a miner tries to include invalid transactions in the blockchain, they will be essentially prevented from doing so by the rest of the network, and they would lose the electricity that they've burned in the process. So with proof of work mining, electricity is the trust collateral, and when a miner attempts to lie or cheat the network, they lose that electricity, they lose that value, and so that is the thing that keeps them motivated to be trustworthy, and that sort of establishes trust on a proof of work network.
Right, and that makes sense. And really, I mean, it is truly like using computing power for the sake of using computing power. It's solving these random cryptographic puzzles with the intention of a fixed difficulty, so that you have to spend money to solve the algorithm. It's not something that it's intentionally obtuse, I guess, right? It's designed to be a barrier to entry so that people can't just, there has to be something that you're trading, or else you're just minting Bitcoins for yourself and it's, super easy and fun. That's
Yeah. And some examples of this. So Bitcoin was obviously first, but then, Litecoin, Dogecoin, a lot of the Bitcoin forks that came after Bitcoin, and a lot of the early blockchain projects, they all, they copied off of what existed, because there wasn't much else.
Right.
So a lot of these early currencies are proof of work chains that all have their own blockchain, and they have their own set of their own network and their own set of miners that are specifically mining for that particular currency. Ethereum is another instance of it, though it is moving away from proof of work into our next consensus mechanism, which is called proof of stake.
Yeah, I think this is something we teased in episode 2, maybe episode 3, something like that. This big change to proof of stake, and now we get to finally explain what it is. And this is one that's coming up maybe sooner rather than later, right? Ethereum has always planned to switch from proof of work to proof of stake, but the timeline rather unknown. And now it's starting to come into focus that this might be an actual priority in like a year, maybe 2 years kind of time.
Yeah, I saw a poll today from some of the top Ethereum researchers that are all leading toward getting proof of stake fully merged in within 2021, which is super exciting. And the move from proof of work to proof of stake has been very much, in the case of Ethereum, long awaited. It is not the first proof of stake chain. There's a few others we'll get into, but first, at a high level, proof of stake is a departure from the idea of burning electricity and using electricity as the trust collateral. So instead, proof of stake works by instead of miners, you have what are called validators that stake tokens in that currency. So in the case of Ethereum, validators require 32 ether to become a staker. They lock their 32 ether in a smart contract that allows the network to sort of hang on to it and makes it so that they can't access it and try to take it away until they've done the work of validating the network in the same way that the proof of work chains do. So they still run hardware nodes that do the work of checking every transaction, seeing that they're valid. And again, if they try to lose or cheat the network, instead of losing the electricity that was burned, they lose the ETH that they have staked. There are different mechanisms for punishing different actions accordingly. So if someone is deliberately trying to include invalid transactions, they can lose their full stake pretty quickly. If they propagate some information from some other node that included some bad transactions, then the punishment gets less and less. But the idea here is that we're moving away from this needless burning of electricity toward using the token itself as the trust collateral. So the reason, go ahead.
Well, so collateral is like the key word we keep using that I think, like, if you had to summarize this whole discussion into one thing, it's what is the collateral to verify the network, right? That's the kind of thing we're talking about here. And shifting it from current, it's such a meta concept. So many people have the currency now, right? There's so much ETH out there that these people with, 32 ETH is a lot. They're worth like 2,000 a piece right now, right? So that's a substantial amount of money. We're talking about like $50,000. You put up $50,000 and say, hey, instead of paying for the electricity, I'll put my money in escrow right now because I know that I'm a good actor. And as long as I continue to be a good actor and verify everything the way it should be, I get my money and then some, right? I get those precious mining fees that used to be your reward. It's, I guess, some sort of like a staking reward or whatever. So it's sort of like almost a form of interest if you're somebody that has enough ETH that you're comfortable putting it on the line. That's pretty cool.
In both of these cases, networks have evolved on top of the constraints that exist at the blockchain layer. So in the case of Bitcoin and other proof of work chains, at the social layer, people have created what are called mining pools, where instead of every person for themselves trying to run their solo hardware and get their small piece of reward fees once every X number of months, they pool their hardware and hashing power and divvy up the rewards accordingly. So you might join a proof of work mining pool that you are maybe one of 100 miners, and every time any of them happens to mine the next block in the blockchain, then those rewards get divvied up proportional to the amount of hashing power that you've contributed. Similarly, in proof of stake, people have created what are called staking pools, and there are a few different ones right now for Ethereum. The Rocket Pool is one that's coming out that'll be a bit more decentralized than what exists now. I know Coinbase is planning to offer staking through Ethereum. There's a few others that exist now. So all of that is to say, you don't necessarily need the full whatever 32 ETH is right now.
Gotcha.
You could decide to stake just a small portion of that and be able to help validate the network.
Okay. Very cool.
Yeah. And so the next couple examples of mechanisms are sort of mentioned here as kind of honorable mentions. One variation of proof of stake is called delegated proof of stake, and that just adds an additional layer on top of proof of stake, where instead of every individual staker staking separately, it sort of like builds this concept of voting into the act of staking. So you could stake your currency toward an individual delegate, and then that delegate can sort of like be a pool of different staking amounts that equal out to whatever. Examples of this: Polkadot, Solana, Cardano. These are all sort of attempting to kind of build some of this like pool, like staked pool, pooled stake mechanic into the underlying consensus mechanism.
Okay, interesting. And these last couple, I have no idea what we got going on here. Proof of elapsed time. Kevin, tell me about this, please. This sounds awesome. So the future has arrived, man.
Yeah, again, it's alternatives to burning electricity, or in the case of proof of stake, like having to worry about the token value within the network. So proof of elapsed time is another mechanism of building this hashing function that allows other nodes on the network to know that X amount of time has passed from the previous block. And without going into a ton of technical detail, it's this additional alternative that exists for the purpose of trying to be green and trying to not involve burning electricity. And the next one, proof of elapsed time, one example of that is the Chia network. And then final one for this list, there's sort of like endless small experiments for different consensus mechanisms, but proof of capacity or space or storage. All of these are just different ideas around using hard drive space as the mechanism to sort of like prove something to the network that can be, used as the trust collateral.
Okay, so you're staking hard drive space, so you could just buy a shitload of hard. That seems regressive. That seems like it's just like proof of work mining, except. I mean, hard drives use power too, so it's not as bad, but it's similarly obtuse.
Yeah, it's just all of this is to say that there's a lot of experiments going on. A lot of different.
So proof of stake is really what we have our eyes on, I guess, specifically as it relates to Ethereum. And I guess to be clear, it's like almost like a pre-lightning round question here. Bitcoin not planning on going to proof of stake, correct? Like
that's correct.
The plan for Bitcoin is proof of work all the way out.
Yeah. There at this point, there's no one in the Bitcoin talking about changing that. And yeah, proof of stake seems to sort of have become emerged as kind of the way that projects are moving between Ethereum and all of the other smart contracts platforms, at least.
Gotcha. Very cool.
Yeah, and like the different trade-offs that exist for these different proof of X, Y, Z consensus mechanisms, they sort of dictate how and when different blockchains decide to use them. So, I mean, first and foremost, when Bitcoin was created, there was no alternatives, and so it was like the first attempt at solving global money. Satoshi Nakamoto may not have known that their project would become so successful that it would start to burn a hole in the ozone. And so it's, the trade-off number one is the more successful proof of work becomes, the worse it is for electrical consumption. And additional trade-offs around decentralization of that, mining costs become more and more prohibitive over time. Just the centralization that comes with one or two companies producing all of the mining hardware that exists.
Yeah, I mean, even within that, right? So mining Ethereum, that's something anybody with a graphics card can do, or at least that used to be the case. And back in 2018, during the ICO boom, I have a lot of extra hardware laying around. I had a couple of the studio computers, a couple of those 970s and the 1070s spinning up. And back then, it actually worked. Now you need a certain memory buffer just to be able to hold the blockchain to be able to do mining. So there's a lot of hardware that you used to be able to do it with a relatively standard graphics card. Now you need a pretty good, expensive, like you're a serious gamer kind of graphics card just to be able to consider getting into mining. And really now it's geared for people with these big rigs, these more kind of industrial setups. But it very quickly floats towards the top, just even from a technological standpoint, even if that's not necessarily by design, right?
Yeah. And the one thing that Bitcoin maximalists will often point to as what they see as sort of the pro over proof of stakes cons is this idea of the value that is taken in, that is converted into trust, comes from outside of the network. It comes from the cost of electricity, and this cost exists in sort of the human meat space, and it is something that is totally pegged separately from the value of the network.
Right.
And so they're saying that like this is something that is stable, and the value of the token may change over time. And as opposed to proof of stake, it is relying on the value the network to be sort of the security mechanism. Like if the price of the token were to drop, the requirement for staking would become higher to secure the same secure the network in the same way.
That could create this sort of feedback loop in a bad way, the unraveling effect, sort of, if for some reason trust in the network is lost from some other sort of external factor or something.
Yeah, and like there's some other trade-offs that kind of go push back against that idea, or some other where like in the case of in proof of work with a 51% attack, when a network is attacked in that way in the proof of work world, it's kind of hard for the network to sort of evolve from that. Where if someone has the power to attack some network, then they have that. And in proof of stake, the person that is found to be attacking the network gets slashed and gets their stake removed every time they attack. So even if it did suffer from the sort of like equivalent of a network takeover in proof of stake, the attacker would start to lose their ability to attack the network as they're attacking. So anyway, all this is to say that there's a lot of conversations going on in this new field of mathematics and economics toward coming up with the next great consensus mechanism.
All right. So is it time for some lightning round, bud? Is that where we're at?
I think let's jump straight into it.
All right.
So, can you run a node without being a miner staker?
Yes, the short answer is absolutely. So, as we mentioned before, a node is really just a copy of the blockchain. So, when I first started mining Litecoins, I set up a node so that I could see my mined coins syncing with the blockchain kind of in real time. It was fun to wake up every day and see, all right, another zero point 0.1 Litecoin. Here we go, right to the moon. But that was just a little MacBook Air that I needed 4 GB or so to have a copy of the Litecoin blockchain, and that doubled as my Litecoin wallet. And that is a node. I was running a little node that is a copy of the network that does help add to its integrity by some little tiny amount. And that is separate from mining, right? The miner that I was running also serves as a node. If you think about the miner like working on the blockchain and having to interface with the network, pretty hard to work on the blockchain if you don't have a copy of the blockchain. So every miner also doubles as a node, but not every node is necessarily a miner, right? A node is just something that any computer can run. Mining requires some specific hardware that's, kind of high powered for that kind of thing. So
Yeah.
small difference there. But what happens when consensus fails, right? Surely sometimes it doesn't all work out and the network still has to go on, right? What do they do?
Yeah, and this is a throwback to episode 3. We had this question in the lightning round, and I want to hit on it again. It does look different for each consensus mechanism and the reason that it failed. So in the case of a disagreement in the network, consensus failure looks like a fork. Now there's 2 versions of the blockchain. In the case of a 51% attack on a proof of work network, we just saw this last year with Ethereum Classic. In 1 month, they were attacked 3 times, and the attacker was able to rearrange something like 7,000 blocks, or like a few days worth of transactions that existed. And if that had happened on any network that anyone really cared about, or it was really moving any amount of value, that could be very problematic. And the size of the network really does dictate what is capable of happening, and what an attack can sort of get away with. Because in the case of Ethereum Classic, you can think of this as sort of like a DDoS, a distributed denial of service attack, where yes, theoretically, you could have a website and it could be attacked and sort of like denied service by continually a user hitting against it and trying to request it. But like that attacker has to pay for that to happen. And similar to DDoSes, like if 51% attack were to attack a network like ETH Classic, or even a larger one to attempt something like Ethereum, would require huge amounts of capital. And so a lot of times in the past, what we've seen is that these 51% attacks sort of like happen for a short period of time. Maybe they rearrange a few blocks. But like it really needs to be, there needs to be financial incentive for the attacker to do that sort of attack, because if there's not, like, you're going to be wasting a ton of hashing power just hitting some chain until the value of it plummets, and then like what have you necessarily gained?
Right.
Yeah.
Right. I think there's like in your head, you sort of think, oh, once you own 51% of the network, it's just over. But no, you need to maintain 51% of the network to really do meaningful damage over a long period of time. And that's what you're pointing out. To do that is so cost prohibitive that, yeah, sure, you might hate Ethereum Classic or think it'll boost some of your other investments, but it's a big upfront cost as a bad actor with no guaranteed return. Taking that coin to zero doesn't necessarily get you anything. It's more like a theory of assured mutual destruction, which has all sorts of weird game theory implications. So,
yeah. And also a chain can always fork and change its consensus. So
true.
At the end of the day, if you're a proof of work network and you're getting 51% attacked, you can always switch to proof of stake.
Yeah.
And not have to deal with that.
Gotcha.
Cool.
So,
yeah, next question. Yeah, what happens if too many nodes go offline at the time? I'm imagining some sort of an EMP or a nuclear weapon, or even just, a country having their internet shut off?
Yeah, so a hard question to answer because there isn't a magic number of like if 20% of the nodes go offline, then the whole network goes into turbulence. It's more this sliding scale. The more nodes we have, the more decentralized they are over a wide breadth of locations and people and cultures, the better. And it's a sliding scale the other way. The less we have, then the less integrity the network has. It's sort of an interesting thing to think about in terms of hardware for proof of work, at least being centralized around eco renewable energy. Iceland comes to mind, right? A lot of hydro energy there, which is great, but if a volcano erupts or something and we lose some huge part of the mining power on a specific network, that could absolutely make it vulnerable to some sort of a 51 attack or something else. So I guess nodes going offline is maybe a little bit less scary. A huge portion of miners getting destroyed, if something happened where all of China went dark, there's a huge amount of mining power there. That definitely does have some interesting implications. If other actors wanted to collude, combine their mining power, things could get really crazy. So by nature of the network, the integrity is always increased by more decentralization. I think that's a truth that we'll pretty much always go back to with this kind of stuff.
Yeah, absolutely.
So last question here. Do we need any more blockchains? What if I've got a really good idea for, we've got Litecoin. What if I want to make the bronze to Litecoin silver, Kevin?
Oh my God.
I bet somebody's probably tried to do that already, yeah. Zyori Lite, we'll call it,
Yep.
Is that a good thing? Can I even do that at this point? Is that practical?
I would say not really, at least not creating it as its own blockchain. So what we've seen over time is early on, projects would create their own blockchains, and they would sort of have to compete with all of the other blockchains to attract miners, to attract people to run the software. And you can think of that hardware and software that's running as sort of the limited resource that exists that powers the security of a blockchain. So if there's only X number of miners on any given day, they are all competing to a degree to mine for the different blockchains that accept their hardware.
Mm-hmm.
And so early on, we saw these projects that were popping out their own blockchains and competing for smaller and smaller pieces of the limited security resource. And so this what we've seen since the creation of Ethereum and these larger smart contracts platforms is this idea of having a more generalizable blockchain that exists as the security platform and the security layer for other projects and currencies and tokens and software to run on top of it. And instead of having every single one of those projects compete for this limited security resource, we could pool all of that security resource to secure the entire network. So now if you compare something like Dogecoin or Litecoin to something like any token that exists on Ethereum, Aave, Compound, we'll get more into DeFi tokens at some point, but if you compare the security of these two styles of tokens, you have these small blockchain with these small sets of miners on the proof of work side that wouldn't be a huge barrier to entry to attack compared to something like any currency that exists on Ethereum. You have to break all of Ethereum to break any of those individually. So we're more so seeing this idea of trying to pull together the security resource to run more generalized software. And then that way, every currency doesn't have to compete with every other currency to exist.
Right. So like by running some GPU miners that support Ethereum, I'm kind of by virtue supporting the network that supports every other coin that was created on top of Ethereum. Like any ERC20 token, you're helping all of them. They're all kind of working in tandem. That's kind of cool. That's almost a twist now where a little bit of centralization is turning into a good thing. Look at you, Kevin.
Yeah,
look at you coming back towards the middle, bud.
Yeah,
Whoa,
I mean,
whoa,
think of it this way. Let's before
whoa.
we start mincing words here. Uh, centralization isn't always bad. It's all about the axis that we're talking about.
Hmm.
Like when you're talking about like fragmenting security versus centralizing it, like yeah, all day. Let's pull together all over the security resource, whether it's miners or stakers or just generalized blockchain. Let's centralize that because that is the
Yeah.
layer at which it's actually benefiting the entire network if we
It's
if we
like
centralize
going
there.
back to that onion. If the inside found, if the core of the onion, the foundation is decentralized in nature, i.e., the miners or the stakers, then we don't need to keep building decentralized layers on top of that because, well, now it's inefficient, right? We can trust the decentralization on a basic layer and then build some things on top of that that are a little more trustworthy and maybe a little more recognizable from like a conventional sense. Damn, dude,
Yeah,
that's awesome. That's some heavy shit
yeah.
right there. I like it.
Some cool beans to leave it on, I
Whew.
think.
Wow, that's a thinker. Man, my brain's going to be spinning when I make dinner tonight. All right, buddy. Well, Kevin, man, thanks a lot. I always appreciate you breaking down these heavy topics for me, helping dummies like me understand this stuff. I certainly appreciate it. I know there's a couple of people out there that appreciate it as well. But I think until next time, you want to tease what we have coming up next? Do we know what we have coming up next?
I take this one step at a
One
time.
step at a
Yeah,
time.
I
All
think
right.
before we hit that record button, we think about it. But yeah, something will be good
All right. That's great.
coming up next. Yeah, that's
We'll
all I'll say.
we'll see y'all next week.
Later.